So Charlotte running at a rate of 9 kilometers per hour. And what is their speed in meters per second? So let me write down our starting rate, 9 kilometers in 1 hour. And we need to change it to meters per second. So converting kilometers and meters, we know that in 1 kilometer, kilo meaning 1,000, there are 1,000 meters. And we know that in 1 hour, well, we can first convert it to minutes and then convert minutes to seconds. But in 1 hour, there's 60 minutes and every minute has 60 seconds. So 60 times 60, there are 3,600 seconds in 1 hour. But if you want to do it in 2 steps, you can do that as well. So 1 hour is 60 minutes and 1 minute is 60 seconds. So if we do this in 2 steps, so 9 kilometers an hour times by, well, we need to cancel out hours. So 1 hour up top and 60 minutes down below. And then we need to cancel out minutes. So we put minutes up top and seconds down below. So every 1 minute is 60 seconds. But you can see in the end that you end up dividing by 60 times 60, which is 3,600. So if you need to do it in 2 steps, feel free. It definitely works. But once you get good at it, you can effectively just do it in 1 step. And now we got to cancel out kilometers. So let me make these cancellations really quick. So we're at kilometers per second, but we need meters per second. So we need to cancel kilometers. So put that in the bottom since it's up top. So those cancel. And for every 1 kilometer, there's 1,000 meters. And so now we just do the multiplication. So 9,000 when we go across the top, divided by 3,600 when we go across the bottom, and that's meters per second. And this simplifies to 2.5 meters per second. So let's do 2 more of these. So we've got Mia painting an interior wall at a rate of 12 square meters per hour. So let me write that down. We've got 12 square meters in 1 hour. And we need to change this to square centimeters per minute. So we're converting hours to minutes and converting square meters to square centimeters. So we know that in 1 hour that there are 60 minutes. That one's not too bad, but the other one's a little bit more complicated. So I'm going to draw a square because we have square units. And so we have 1 meter here, 1 meter here, but we need to change this to square centimeters. So we know this is 1 square meter because 1 times 1 is just 1. So now let's use our centimeter units. So I'm going to put 100 centimeters here and 100 centimeters there, since 1 meter and 100 centimeters are equal. And so to find the area of this in square centimeters, you multiply 100 times 100, and you get 10,000 square centimeters. And now that we have the correct units, let's do our multiplication of fractions. We want to put square meters down here, and so square centimeters go up top so that the meter square cancel. And for every one of these, there's 10,000 of those. And we're going to put hours up top so that it cancels with the hours down below. For every one of those, there are 60 minutes. And now notice we have square centimeters per minute, which is what we want. So let's actually carry out this multiplication. And we can make some simplifications. So 1 0 here and 1 there cancels out. 12 divided by 6 is just 2. So you have 2 times 1,000. So that'd just be 2,000. So 2,000 square centimeters per minute is the same as 12 square meters per hour. And let's do one final problem. So an electrolyte solution has an average current density of 1 ampere or amp per square decimeter. What is the current density of the solution in amps per square meter? So let me rewrite this. We have 1 amp per square decimeter, and we want to change this to amps per square meter. And just so you've seen it, before we try and convert meters squared to decimeters squared, let's look at a metric conversion chart. Just because this is something that's very valuable to see. So here you have this chart, and you can just Google this. I literally just Googled metric conversion chart and found this in the image section. Lots of different images like this can be found, but you essentially have this is your starting unit, 1. So this could be meters, it could be liters, seconds, whatever you want. This will be your base SI unit. So let's just say meters, just to make it simple. So kilo means 1,000. So 1 kilometer is 1,000 meters. If you have giga, which you tend to see more with computers, or tera, or even peta, computers are now getting pretty big in their hard drive storage, but you might see giga with, like I say, computers, but we can do it with meters too. So 1 gigameter, or gigameter, there'd be a billion of them. So 1 billion meters, or I'll just write 10 to the 9th meters. And if you go the other way, you see you have deci, centi, milli. So milli is 0.001. So 1 millimeter would be 0.001 meters. Or maybe we go all the way to nanometers. So 1 nanometer is 0.000000001 meters. So it's a billionth of a meter. So that's the general idea for using this. So we're using decimeter. So 1 decimeter is the same as 0.1 meters. So it's smaller than a meter. So let's use this information to now answer our question. So we need to change our 1 amp per square decimeters into amps per square meters. And so we just figured out that 1 decimeter is equal to 0.1 meters. And I'll write that on the other side, 1 decimeter. Oops, that should be dm. And this is equal to 0.1 meters. So when we find the square unit, 1 square decimeter is equal to 0.1 times 0.1, which is 0.01 meters squared. And again, from here, you could just square each side. So 1 squared is 1, 0.1 squared is 0.01. And with this, let's actually convert our units. So we're taking our fraction here that we start with, we're multiplying it by this equivalency here. And we want decimeters up top, or decimeters squared. And for every one of those, we're going to get 0.01 meters squared. And so with this, we can actually do our division, since these units cancel out, and we get amps per square meter. So 1 up top divided by 0.01, well, that would just be 100 amps per square meter.